Assalamualaikum. Hi everyone. Hope everyone is doing fine. So today we're going to continue with chapter 2, frequency modulation part 3. Okay, frequency spectrum. Frequency modulation has infinite number of frequency spectrum. This is because in a frequency or phase modulator, a single frequency modulating signal produces an infinite number of pairs of side frequency. Therefore, it has an infinite bandwidth. However, most of the side frequency are very small in amplitude and can be ignored. So as obtained in equation 10 in part 2, our lecture on part 2, the FM modulated signal is given by VFM is equal to VC cos omega CT plus MF sin omega MT. Further expansion using trigonometric identity, we use cos A plus B is equal to cos A cos B minus sin A sin B. Therefore, this equation VFM will become something like this. Okay, the term cos MF sin omega MT and sin MF sin omega M of T can be further expanded as trigonometric Fourier series. By using bessel function of the first kind of nth order, the FM mathematical expression become as this equation 15. So this is the new equation using the bessel function. From equation 15, it shows that the FM waveform has component at the carrier frequency and unlimited series of frequency above and below the carrier frequency. Okay, from equation 15, J0 is actually the amplitude of the carrier. J1, the first set of side frequency displaced from the carrier by omega m. The J2 is second set of side frequency displaced from the carrier by 2 omega m. J3, third set of side frequency displaced from the carrier by omega m. Therefore, up to the n number, Jn, n set of side frequency displaced from the carrier by n omega m. Okay, so this is the Bessel function table for several value of modulation index. Let's say if our MF modulation index is equal to 1, therefore, we have J0 is equal to 0.77 and we have the number of side band is equal to 3 pairs, J1, J2 and J3. J0 is actually the relative amplitude of the carrier component, whereas J1 up to J14 is the relative amplitude of the side band components. Okay, from the Bessel function table, when MF is equal to 0, it produces 0 side frequency. The larger the number of MF, the more set of side frequency produced. The value shown for Jn are relative to the amplitude of the unmodulated carrier. For example, if J2 is equal to 0.35, it indicates that the amplitude of the second side frequency is equal to 35% of the unmodulated carrier amplitude, which is 0.35 Vc. A side frequency is not considered significant unless it has an amplitude equal to or greater than 1% of the unmodulated carrier amplitude. Your Jn bigger or equal to 0.01. Number 5, the relative amplitude for the sideband equal to Jn is unitless. And lastly, actual amplitude for the sideband, Jn times Vc. The unit is volt. Okay, how to plot FM frequency spectrum? So this is the one, your J0, and this is the side frequency, J1, J2 up to the Jn, and on the left side also J1, J2 up to the Jn. And the middle here, if you're FC, and then FC plus FM, FC plus 2Fn, up to FC plus NFM. On the left side, FC minus FM, FC minus 2FM, FC minus up to the NFM. Okay, if you apply modulus on the amplitude Jn, there will be no sideband with a negative amplitude. Okay, bandwidth requirement for FM signal. FM signal contains an infinite number of side frequency, so theoretically the bandwidth which required to transmit the FM signal is infinity. Put in practical, significant sideband are limited depending on the value of MF. A side frequency is not considered significant unless it has an amplitude equal to or greater than 1% of the undirected carrier amplitude, whereby your Jn is bigger or equal to 0.01. Okay, there are two different methods can be used to calculate the FM bandwidth. The first one using bessel function table, whereby your bandwidth is equal to 2 times number of pairs of sideband times the audio signal frequency, which is equal to 2 times N times FM. This is equation 16. And also can use the second method using Carson rule, the alternative way to estimate the bandwidth of FM signal. The minimum bandwidth is twice the sum of peak frequency deviation and the highest modulating frequency. So the equation will be 2 times delta F plus FM max. This rule is accurate under two conditions. For modulation index, your MF must be bigger than 4, and your relative amplitude of sideband, your Jn is equal to 2%, or Jn is much of equal to 0.02. Okay, let's have a look at example 3. For an FM modulator with modulation index MF is equal to 1, a modulating signal Vm of t is Vm sine 2 pi 1000t, and unmodulated carrier Vc of t is 10 sine 2 pi 500k of t. Determine a number of set of significant side frequency, B, their actual amplitude, C, draw the frequency spectrum showing their actual amplitude. So using the bessel function table, so what we have here, when our MF is equal to 1, number of sideband is 3 pairs. Okay, 3 sets. Okay, next, to calculate the actual amplitude, J naught, so what we have here, 0.77 times 10, J1, 0.44 times 10, J2, 0.11 times 10, and J3 is 0.02 times 10. Okay, to draw this frequency spectrum, so recap, this is what we need to draw, J0, J1, J2, up to the Jn, and also the same at the left side. So this is what we have. When our frequency FC is 500, so our J0 is 7.7. So J1, 4.4, 1.1, 0.2. This is the same as this one. All right, next, example 4. For an FM modulator with a peak frequency deviation, delta F 20 kHz, a carrier modulating signal FM is 10 kHz, VC is 15 volts, and 500K carrier. Determine actual bandwidth from bessel function table, approximate minimum bandwidth using Carson rule, and C, plot the output frequency spectrum for bessel approximation. So again, using the bessel function table, okay, MF is equal to delta F over FM, which is 20 over 10, which is 2. Okay, referring to table, when your M is equal to 2, your side frequency is 4 pairs. So bandwidth is 2 times 4 times 10, which is 80 kilohertz. Using Carson rule, 2 delta F plus FM, what we have here, which is equal to 60 kilohertz. All right. So when we want to plot the frequency spectrum, this is what this example frequency spectrum look like. All right. Okay. At the end of the lesson, part 1, part 2, and part 3, students should be able to understand the concept of frequency modulation technique, sketch the waveform, write general FM mathematical equation, determine frequency deviation and also the frequency swing of the FM signal, understand the information given in the bessel function table, sketch the FM frequency spectrum, and also calculate the bandwidth using bessel function table and also using the Carson rule. Okay, class, so that's it for part 3. So if you have any question, so do not hesitate to ask me. So thank you very much. Until our next class. Take care. Thank you very much.